Hi everyone, this will be your video for function operations. You can expect to see adding, subtracting, multiplying, dividing, and even composition of functions here. So our first example, these should be fairly similar and familiar for you, but we're just going to go through so you can see all the tips and tricks, make sure we're not making these little silly mistakes. When you're adding or subtracting, you just need to remember you're basically just combining like terms. So that's what I'm going to write here. Combining like terms. Okay, that's like the idea. All right, so our first one, you can see the notation is a little bit different between the two, but whether or not you see, for example, f plus g of x, or if it was written like this, f of x plus g of x, they mean the same thing. Okay, so they're the same. It's just different notation, different ways that it could be typed out. So let's look at A first. All right, so in A, we have our h of x. They're asking us to add f of x plus g of x. So my suggestion for you is to remember that this is your variable. That's what's going to be in place of your variable in the end. If it's x, your end result will have x's in it. If it's a number, your end result will be a number. So we want to add these together. So we're going to add, this is our f of x, which is going to be 3x plus 8. And we're going to add to it our g of x, which is 2x minus 12. Combine like terms, and we end up with 5x. Let's see, so we have an 8 and then a minus 12, so it's going to be a minus 4. And that's your solution. It's that simple. So now let's look at B. So B was a little bit different. There's a little extra step here. When we're looking at B, they're asking for 2 f of x minus g of x. So what I need to do first is figure out what 2 f of x is. So f of x is 3x plus 8. So you can see how I kind of just replaced f of x with the expression that it equals, minus our g of x, which is 2x minus 12. So notice how these are in parentheses. You want to make sure you're keeping them in a group. Okay, the reason why is that minus sign goes to everything in the group. So using some simple algebra skills, we can distribute. So we'll end up with 6x plus 16. We can also distribute this minus sign. That's why it's nice to keep them together. So we end up with minus 2x and then a plus 12. That's where most of your errors are going to come into place here. Combine like terms for your final answer, we end up with 4x, and then we have 28. So when you are giving your final answer, you do want to make sure that you're answering all parts of the question, and one of the parts up here that we kind of skipped over so far is that it's asking for the domains. So it's okay if you forget what this is. We're going to talk about what your domain is for a second. And the domain is going to be your possible x values. And we know that x is our input. So basically, what numbers can I put into both of these equations? So for our bottom one, for B, you can put in any value. You can plug in negatives, you can plug in positives, you can plug in fractions, decimals, does not matter. Anything will work. So your domain would be all real numbers. Now for our green one, we're also going to have that same result. Most of the times when it's just a polynomial like this, you can tell that, all right, I can plug in anything. So this one's domain is also all real numbers. So make sure that you are answering your questions fully. That way you make sure you get full credit. All right, so next up we have similar type questions, but now they're asking for multiplying and dividing. Again, it's the same idea as we're just combining. We're just doing whatever operation they're asking for. So let's look at A first. A is asking for f times g of x. All right, so we're just going to multiply these two functions. We have x squared minus 1. That's our f of x. And our g of x is x plus 5. So you can do your good old-fashioned FOILing. So our first terms will give us x cubed. Outer is 5x squared. Inner is minus x. And last is minus 5. Combine like terms if you can. If you can't, then that's about it. Let's do our domain while we're here. So we have a polynomial function. If you look, that there is nothing that I cannot plug in. If you try to plug in a negative, it works. If you try to plug in a positive, it works. Fractions, decimal, it all works. So your domain would be all real numbers. Now on to B. B is our only one where we might actually have a domain restriction. So in B, we are asked to find f of x divided by g of x. So when I write my problems out here, I have x squared minus 1 over x plus 5. Now, sometimes you do have to simplify a little bit. So you do want to make sure that you're looking out for some, patterns that you might recognize. For instance, this x squared minus 1, that's a difference of squares. Okay, and with difference of squares, you can break them up, and you break them up into two binomials. So this would actually be broken up into x plus 1 times x minus 1. And you get that by taking the square root of your first term and then your square root of your second term. And so difference of squares, different signs. So we have that factored, and then we have x plus 5 underneath. So the reason that we do this is sometimes you can cancel out factors, and if you can, do it. You always want to simplify as much as possible. So we do need to figure out our domain. So the biggest issue here is if we look at our denominator, it cannot equal 0, right? We cannot divide by 0. Okay, so let's take a note here on how to find our domain. So to find domain, set denominator not equal to 0 and solve. And that's going to tell you the values that will not be included in your domain. So for instance, we're going to set x plus 5 not equal to 0. So that lets us know that x cannot equal negative 5. So that is our domain. So when I'm filling out my final answer, I'm going to switch back to green because it belongs together. We can write, just like you do, like a little semicolon and say x cannot equal negative 5. Okay, and finally we have a couple notes on what a composite function is and how they're going to look for you. So when we talk about a composition or a composite function, the two ways that you're going to see it written, you can either see it as f of g of x, and you can see how that's like a tiny little open circle, kind of looks like a tiny little O. And then you could also see that written as like f of g of x. Now personally I like to put whatever one's on the inside a little bit smaller. Helps you visually see which one's on the inside, what to input. Now you can also switch it up, and then we can have g of f, right? So now the order is different. It does make a difference. So now we have g of f of x, or you can write it like in this notation where it's g of f of x. Okay, so one last thing before we get started on examples is that when you are evaluating them, you're going to evaluate the inside function first. Okay, and that should make sense. Whatever function is on the inside of another function, and that's just if you're evaluating. So we're going to do just one of these examples, and we're going to do it in two different ways. So the first thing we're going to do, we're just going to find f of g, and then we're going to find, and then our second problem is going to be, we're going to find f of g of 2. You know what, we're going to make that a 2a. Okay, we're going to get a little weird with it. So let's do this first example first. So they're telling us our f of x is 2x squared minus 5, and your g of x is negative 3x plus 1. So when you're doing that, you figure out what function's on the outside, and our f is on the outside. Okay, so we're going to write our f function first. So I'm always going to notate what I'm finding here. So I'm finding f of g of x, and I'm going to put my f on the outside. So I have 2x squared minus 5. Now what I'm going to do is, you can either not write that x, or you can write it and erase it like I'm going to do. And we're going to give a little bit of space here, because I know I'm going to be replacing that x with my other function. So this is going to be 2x squared minus 5 And on the inside here, now we're going to have our g function, which is negative 3x plus 1. You know, I did not give myself enough room. Let's make that just a little bit bigger. All right, let's try that again. So we end up with 2 negative 3x plus 1 squared minus 5. So that's a little bit better for you. So you can see that I've replaced my x from my first function with whatever my inside function was. You do need to follow the appropriate order of operations. So for instance, we need to square this monomial or binomial first. You cannot just distribute the square into it. You need to FOIL this. So that's a note I'm going to write for you guys, is to make sure you FOIL. That is a big, big mistake a lot of people always make, is to not FOIL that. You do not distribute the 2 in, right? If you think about your order of operations, you do exponents first, then you multiply. So we're going to leave the 2 in the front. We're going to FOIL this. So if you FOIL it, you can do a little bit of mental math with this. You square the first term, so we're going to end up with 9x squared. You're going to multiply your 2 terms together. So I have negative 3x and then times 2, so that's going to be negative 6x and then plus 1. But honestly, just write it out and FOIL it and you'll be good to go. So then I have minus 5. Now we can just keep using a little bit of algebra skills. So we're going to end up with 18x squared minus 12x plus 2 minus 5. And then we're going to have, let's see, we have 18x squared minus 12x minus 3. So this is our f of g of x. And you can rewrite it if you'd like, just so we know what we found. Now we can use this for our second answer, our second problem. So when we go over to the second problem over here, I'm looking for f of g of 2a. So I've already found f of g. Now they're asking me to input 2a. So everywhere you see an x, you're going to replace with 2a. So you're going to replace all variables with 2a. So you might see just numbers here, for instance, as in the examples above. You might see just an a, you might see a 2a, you might see a whole nother expression. So make sure that you're careful where you're inputting and you will be fine. So I'm just going to scroll this page up and we're going to do it down here below. So we're going to find f of g of 2a. So everywhere I see an x, I'm going to place x with 2a. Minus 3, okay. And now we need to simplify. So this is a different situation. We can just distribute the exponent because this is a monomial. So that is okay. You just have to make sure you square the 2 and the a. So we're going to end up with 18 times 4a squared minus 24a minus 3. And then we just have to do 18 times 4. Okay, so we end up with 72a squared minus 24a minus 3. So you can see that we used the f of g and then we inserted 2a. Now the biggest thing to remember here is that if you're looking over here, you can see how this is an x. Okay, we replaced that x with 2a. That gives you an idea of what we did to get from these two steps. We replaced x with 2a. So keep that in mind when you see any of these problems.